It was an earth mover manufacturing company. They encountered a usual but dangerous problem. They noticed the studs and nuts of the wheel assembly of the dump truck came out loose after a short amount of time in service. Since then, it had been a long-standing problem for them. The design engineers attempted to fix it, but the issue kept recurring. They tried several tricks that didn't work as intended. An unexpected newcomer, a fresh graduate, enters the scene. He was assigned to take on the challenge and tackle the problem that had been plaguing the department. Hi, I am Hilal Alam from ALZEBRA. Let's explore a cautionary tale of a design change and learn from the mistakes of the past. Before entering in, I want to inform you something. I used FreeCAD package, which is an open source parametric 3D modeler made primarily to design real-life objects of any size. FreeCAD is a fast-growing project developed by a community of developers. FreeCAD is free. You can kindly donate any amount to it. The money you donate to FreeCAD project will be received and handled by FreeCAD Project Association, a non-profit association created by FreeCAD administrators and code developers. I am promoting it out of my own interest. Thank you very much. In India, during 1987, a renowned large earth mover manufacturing company was grappling with a common but dangerous design issue. This was causing a major safety concern for their products, and they knew they needed to find a solution before it was too late. Despite the tireless effort of the design engineers, several attempts to fix the issue proved fruitless. The problem was, the studs and nuts connecting the wheel and the tire rim were coming loose after a short amount of time in service. This left the company scrambling for a solution. Let's get into more details. This is a view illustrating the placement of the rim clamps in their original position. In fact, there were 32 or 16 studs and nuts set on the wheel hub, and for the sake of clarity I have shown only 8 sets. This is the state that had failed. See the circle clamp that turn a bit, loosening the nuts. Here I have shown just 4 random clamps that got displaced in this animation. Despite the engineer's initial design, the clamps were unable to secure the studs that shown in red, the nuts shown in grey, and maintain the integrity of the wheel and tire assembly. Hence, they retorqued the nuts every time to bring back to the original torque. In an effort to fix the problem, engineers made several changes to design, not only tightening torque. They altered the bolt material and clamp material. They introduced bolt lock to prevent loosening and even heat treating on specific parts. However, despite of their best of efforts, they were unable to find solutions by solely focusing on the failed parts. The issue persisted and search for the answer continued. Their sole focus was only on the clamp and the studs and nut assembly. At that juncture, our young freshman, designated as a product engineer, was assigned to this problem. He was a fresh young graduate and had just completed the orientation program organized by the company. His role was to handle incremental design work such as field failure analysis, corrective actions, and cost reduction. The first task given to him was to solve the persistent problem of rim clamp loosening. While attempting a solution, he came to know that it was a daunting task and he was determined to find a solution. He gathered all the necessary part drawings and began preparing a layout by assembling the parts on the drawing board. Within a couple of hours, the layout was reasonably ready and the problem was popping out its face uncontrollably. Yes, there was a serious design flaw the young man was able to spot within a couple of hours. The engineers had missed one fundamental issue. To figure out, it's necessary to understand the geometry configuration, how the force were transmitted from the rim to the wheel. Let's begin with parts by cutting out the model to see the cross-section of it. The wheel hub, outer and inner rims, a sleeve, a space, and of course the tires. The fastening system clamps the rim onto the rear wheel hub of a 35-ton off-road dump truck. There were many forged steel clamps and studs were high tensile, properly torqued with Loctite. All were firmly fixed. The studs can withstand several hundred tons of weight. The axial force of sleeve locks the inner and outer of 2 rims by friction. In other words, there has to be sufficiently rigid surface on either surface of the wedge-shaped feature to keep things in equilibrium. The tapers in the rims were the key features that held the rims perfectly concentric to the wheels and enabled the load to be transferred efficiently. Something caught his eyes. The young engineer noticed that the inner rim wedge was getting proper support from the wheel while the outer one was not. There was a gap underneath. This gap was causing the outer rim to bend slightly and the clamp to come out loose. Thus the firm grip between the sleeve and the clamp was lost. The young engineer was then able to make a critical design change with one masterstroke. There is only one parametric change and it solved the problem once for all. All that the engineer did was filling the gap beneath the sleeve. It needed to be filled with material. The sleeve was not expected to withstand any vertical load by bending. The gap made the sleeve to bend and lose the axial force. This change provided a proper support to the outer rim wedge, which solved the problem and prevented the clamps from coming loose. This was a major breakthrough for the company. Thanks to the fresh perspective and determination of the young engineer, that the problem was finally solved after so many failed attempts. In simple terms, the problem was solved by making a small change in the length of the sleeve contact, which altered the balance of the forces between the inner and outer rim wedges. It was a small but critical change that brought a profound impact in solving persistent issues that had plagued the company for so long. This case serves as an example that the part failures should not be analyzed in isolation. The root cause of the failure, even though the problem statement was a rim clamp failure, was not with the rim clamps or the nuts, but with the sleeve length and the gap beneath the sleeve. Hence, the nut used to lose the torque, causing the clamp to come out loose and shift out of the place. This was a dangerous and unacceptable issue. What caused this problem? The original design was from the USA, and since the tire size varied between countries to countries, they changed the design accordingly. The problem was likely to have started when they used a locally available tire that required a change in some of the sleeve and spacer dimensions. However, they failed to note that corresponding change required in the wheel hub casting as well. This oversight led to the imbalance of forces between the inner and outer rim wedges and failure of the rim clamps. Though the young engineer was not credited for his findings, he went on to win several laurels later in his life and eventually retired as a successful executive. Now he enjoys his life as a freelance design consultant. In addition to his professional accomplishments, he also made a difference in the lives of others. He took in an uncared-for dog that lost his two hind legs. A shelter home rescued the dog Vera from street he adopted from them and designed a cot to support its rear body. This effort went viral on the social media and was eventually praised by the Indian Prime Minister Mr. Narendra Modi in 2020 Mann Ki Baat show. This shows that he is not only an engineer with a great aptitude for problem solving, but also a kind-hearted person who cares about the welfare of others, both human and animal alike. He is none other than Mr. Kasi Armugham, a well-known personality to many as well as in social media for his soft voice for the society. With this, I am signing off. I will see you in the next video. Thank you very much. Bye-bye.